Hey everybody! In today's lesson, we're going to talk about the correlation coefficient when dealing with scatter plots. Alright, so before we do that, let's review the different types of correlation. So we already know that there are three types of correlation. We have positive, negative, and then there's no correlation. All right, so it says to draw a line of best fit for the positive and negative correlation examples. So when you're drawing that line of best fit, you're going to try and draw your line in such a way that the numbers or the data points about half are above and about half are below the line. And remember I said we want to get a ruler or some sort of straight edge. You're going to lay it across your screen. And let's see, that looks pretty good. And then always need to have arrows. All right, and then negative correlation gets a line as well. That one looks pretty good. So there we have it. So I've drawn in the line of best fit. Remember that you're not going to be able to draw in a line of best fit if there is no correlation, okay, for the data points. And it also tells us, don't forget, the line of best fit is always in the form of y equals mx plus b. So we're going to highlight that. Now, let's talk about the correlation coefficient. Now, in the last lesson, when we were using the calculator, in our case Desmos, to get the equation for the line of best fit, you might have also noticed there was some extra data. Besides giving you the M and the B, it also gave you an R value. Then that R is called the correlation coefficient. R can be any number between -1 to +1. And that number kind of gives you an idea of the strength and the direction of the correlation of the two variables. Meaning, is it a strong correlation or a weak correlation? And you can also use it to determine if it's going to be a positive or a negative correlation. All right, so if R is at -1, that's as low as it'll go, then we say it's very strong. That's as strong as it can get, and it's a negative correlation. If the R value ends up being a positive one, which is as high as it'll go, that is extremely strong correlation and obviously positive. An R correlation of 0, exactly equal to 0, means there's no correlation whatsoever, meaning your scatter plot is something like this. The points are all over the place. But remember that your correlation coefficient could be the number can be any value between -1 and 0. So you could have a correlation coefficient of -0.78, okay, or positive 0.89, for example. All right, so looking here at this one, this is showing us a very strong positive correlation. So we can look at it until it's positive. You should be able to look at it until it would be strong because the data points are pretty close to that line, which means the R value for this would be close to 1. Now, it wouldn't be equal to 1, and the reason it wouldn't be equal to 1 because if it was equal to 1, then all the points would be exactly on the line. So that's probably not going to be the case. So this could be 0.8 or 0.9, even a 0.7 would indicate strong positive. The next one is a strong negative. Okay, so this is going to be close to -1. It's not going to be equal to -1 because those data points are not exactly on the line. But it should be close to -1. So -0.7 or -0.8 or something of that nature. This one down here would have no correlation. Now, it might not be exactly equal to 0, but it should be close to 0. So 0.1 or even -0.1 would still be pretty close to 0 and indicate no correlation. Okay, so those are the views, the different views. Let's look here. Let's do a little bit of a practice. It says to determine the strength and type of each of the following correlation coefficients and scatter plots. Answer only the boxes that apply. So the first 4 are just boxes. So if we had an R value of -0.893, well, that's close to -1, pretty close. So we would say it is strong. It's negative, so we're going to say, and it's close to -1, so we're going to say negative. We're going to leave this blank. Okay? What about the next one? R equals 0. They didn't put the 0 part, but 0.432. Well, that's not strong. We would say that's more weak. And is it more positive, negative, or would you say that's no correlation? So for this one, I wouldn't say it's no correlation, okay? So I would go with a weak positive for this. Okay. Look at number 3. R equals negative 0.023. So that's very close to 0. So we're going to say that's going to be pretty much no correlation. If it's no correlation, then you're not going to answer the parts about being strong or weak, positive or negative. Although it would be, if you had to be pushed to make a line, it would be a negative line. But really, we'd say there's no correlation with that. Number 4, R equals 0.872. That's really close to 1, so we would say that's another strong. And it's pretty close to 1, so I would say, it's positive also. And we don't need to answer the part about little or no correlation. So we put a line there. What about number 5? Okay, so now this time we have a scatter plot. So that would be a negative association, right? Would it be strong or weak though? So this one's going to be, I'd say, strong and negative. Number 6 would have a positive correlation or association. Would you go strong or weak on this? I'd say this one would be more weak, okay? A weak positive. And number 7, there's not going to be a correlation there. So I'm going to say no correlation. Okay? All right, so now we're going to use our graphing calculator, in this case we're going to use Desmos, to find the correlation coefficient, or the R value, which you may have noticed yesterday. So this information right here gives you the steps for doing that if you're using a graphing calculator. You don't have to follow these steps if you're going to use Desmos, which is what we're going to do. All right, so it says, using your calculator, find the line of best fit and determine R, the correlation coefficient, round to the nearest hundredth on everything. And then we need to determine if it has a strong positive, strong negative, or no correlation. So first thing that you're going to do is you're going to pull up Desmos, and we're going to we're going to do number 8. You're going to enter in that information in the table just like we were doing yesterday. So I'm going to hit the plus sign and then table. And I'm going to enter in my X values first, which notice they're going across horizontally. So 1, 2, 3, 4, and 5. And then my Y values are 84, 83, 86, 88, and 87. Okay, now I'll follow those same steps for getting the linear regression equation. So hit the plus sign, then that f of x expression. And remember, the equation is going to be in the form of y equals mx plus b. So y1, then you need that squiggly. So you have to hit the ABC button to get the squiggly. mx1 plus b. Okay, and then when I do that, notice not only did it give me the m and the b, it also gives me an r squared and an r value. Well, first let's go ahead and write down our equation for the line of best fit. So we're going to write that down. It's going to be y equals 1.1x, because remember that m is 1.1, and then plus b, which is at 82.3. Then the next thing it's asking is, what does r equal? And remember, it said to round to the nearest hundredth, which means 2 numbers behind my decimal. So my r is going to be 0.84. So what does that mean? Is this going to be a strong positive, strong negative, or no correlation? Well, this value would be closer to 1. So we would say strong positive. So that's number 8. Okay. Now we're going to get ready in just a minute, and we're going to do number 9. All right. So let's go ahead, look at the table here for number 9. And we're going to go ahead And we are going to go to Desmos. And you're going to enter this information in the table in Desmos first. So hit the plus sign again, table, and then my X values are going to be 6, then another 6, 7, then then another 7, then we have an 8. Our Y values are 100, 80, 95, 60, and 50. Go ahead, hit the plus sign again, and then do the f of x expression. So we want y1 squiggly mx1 plus b. Okay, so our line of best fit, we see, remember we're rounding to the nearest hundredth, so that's going to be y equals negative 18.93x plus 205.71. Our R value is negative 0.73. So this is going to be negative, right? And it would be a strong negative because negative 0.7 would be pretty close to negative 1. Okay, let's go to our next page. Okay, so this next page just includes some more information that we have here for this. So we're going to come over here. And it says, using a graphing calculator, determine an equation for the line of best fit for each set of data. So when I get ready to do this, first I'm going to let that north latitude be the X values, the January mean temperatures be the Y values. So I'm going to go ahead, I'm going to go on into Desmos, and just like I did before, I'm going to pull up a table, and I'm going to enter in the north latitude information into my table. So 6, 18, 26, 35, 42, 47, 52, and then 2 56s. And then my Y's are going to be 74, 67, 55, 29, 39, 2, then 35, 29, and 9. And you do need to have this information entered in. So now we're going to get the equation. So my equation, remember that's going to be y1 squiggly mx1 plus b. So my equation, and it didn't say anything about rounding, but let's round to the nearest hundredth here. So I'm going to write y equals negative 1.17x plus 81.79. All right, let's look at the correlation coefficient. So that R is going to be negative 0. We'll round to the nearest hundredth again, negative 0.86. So is this strong or weak correlation? That's the only thing. This one is going to be a strong correlation. And it's strong because it's closer to negative 1. Okay. I'm not going to ask you to sketch a scatter plot, so just put an X through that. Now it says, what does X represent in the equation? Well, if you labeled your table like I did, we know that the X is going to be the north latitude. So I'm going to write that there on my line, north latitude. And Y would be the January mean temperature. Okay, and then number 7, if a city has north latitude of 45 degrees, determine the January mean low temperature using your equation. Okay, so first I'm going to write down my equation. So my equation, it was y equals negative 1.17x plus 81.79. All right, so my north latitude is 45, which we said is the x. So we're going to put a 45 in place of x, and I want you to write all these steps out. So I've got to figure out negative 1.17 times 45 plus 81.79. So I'm going to come back over here to Desmos, and I'm going to type that in, negative 1.17 times 45 plus 81.79. So I get 29.14. So this would be a temperature. So this is, and that is in degrees Fahrenheit. So 29.14 degrees Fahrenheit is what we'll leave that as. Okay? All right, so that was part A. All right, so now I want you to go, let's look at the next page. I want you to do all of part B, which has 7 questions in it. You can skip over the sketch the scatter plot portion, and I also want you to do part C. So go ahead, let's pause the video now and do parts B and C on your own. Hey guys, welcome back. So we're going to check over problems B and C. So for problems B and C, remember that I used Desmos, and I did round to the nearest hundredth where necessary. So here's the first part of problem B. Remember, you can skip the sketching of the scatter plot. And there's the 5, 6, and 7. You needed to be careful in number 7 because when they gave you the 38 grams of fat, that was a y value. So you had to plug the 38 in place of y and then solve the equation to find x. All right, and then C. Now be careful because the x values are years after 1900. So when you see the 90, that's 1990. When I see 96, that means 1996. Okay? All right, so there's the equation that you would have come up with. And then part two said find the number of AIDS cases in 2003. So how many years after 1900 is 2003? Well, that was 103 years. So in place of x in the equation, you had to put a 103, which is how I came up with my value of that 1,259,257 cases. Now, it says what factor does this equation not take into account? And you may have put something similar, but advances in treatment. I don't believe that there the number of AIDS cases was growing at an alarming rate, but there have been a lot of advances in treatment since 1997. So I think that the number of AIDS cases is actually much lower than what it would appear to be. Okay, so that's it for this lesson. Go ahead, submit this assignment. Remember, if you have questions or need help, see me. And you're ready to go ahead and do your independent practice. Good luck with that.